The Squeeze Theorem by Keagan and David. The squeeze theorem, or the sandwich theorem, is a method used to find the limit of a function. A perfect example of where we can use the squeeze theorem is if we were trying to find the limit of x as it approaches 0 of the equation x squared cosine 1 over x. If we use direct substitution in this instance, the equation would be undefined due to there being a 0 in the denominator of our fraction. Now through the squeeze theorem, if we set up an inequality where g of x, our original equation, is between the functions of f of x and h of x, and we find out that the limits of the functions are also equal as x approaches 0, we can assume that the limit of g of x also has the same limit. So how do we find the outer functions of f of x and h of x? We can start by using part of the original equation, cosine 1 over x, and find the ranges between -1 and 1. As seen here. Now if we multiply each of our three equations by x squared, we can get our original function of x squared cosine 1 over x, and our two new functions for f of x and h of x based on the bounds of the original equation. Now through direct substitution, we can find the limit of f of x as it approaches 0. In this case, the limit is 0. And again, through direct substitution, we can find the limit of h of x as it approaches 0. In this case, the limit is also 0. Now if you recall, in order to use the squeeze theorem, the limits of f of x and h of x must be equal. In our case, we can use squeeze theorem because the limit for both as x approaches 0 is equal to 0. Therefore, the limit of our original equation, x squared cosine 1 over x, as x approaches 0 must also equal 0. Shown by the 3D model, we can see f of x here, and h of x here, squeezing the function g of x at the origin 0, 0. Therefore, you can use the squeeze theorem to find the limit of a function. Another example where we can use squeeze theorem is when we want to find the limit as x approaches 0 of the equation x squared cosine 1 over x squared. As vividly shown here, the orange function represents f of x, or negative x squared, and the green function represents h of x, or x squared, while the function g of x is in between. Similarly, the limit as x approaches 0 of the equation x squared cosine 1 over x squared is 0.
I hope that through these equations you have a better understanding of the squeeze theorem. Thank you.